following slide compares how Table 2 and Table 4 ampacities could be assigned to an underground installation installed in compliance with diagrams D10 for cable and D11 for conduit. In this example, consisting of one conductor per phase, the above ground ampacity is less than the underground ampacity for both direct buried cables and conduits, with the size of the conductor selected from the corresponding temperature column. In this example, the above ground ampacity determined by tables 2 or 4 is less than the underground ampacity based on the tables in Appendix D. Therefore, the above ground ampacity must be used and conductor selected from the corresponding temperature column. This slide illustrates how Table 2 and Table 4 ampacities compared to corresponding ampacities selected from Table D11A or D11B when 3 aluminum conductors per phase are installed underground. In this example, the aluminum conductors installed in a raceway have an ampacity selected from Table D11B, 187 amps, which is lower than the Table 4 ampacity of 205 amps. The Table 4 ampacity cannot be assigned, and the conductor size must be selected from the corresponding D11B table. If 3 times 187 amps was acceptable for the load requirements, then no transition conductor is required, since the above ground conductor portion of this installation is sized and has an ampacity complying with Rule 4-006. In all cases, a conductor terminated on equipment marked with a TTR must be sized to the corresponding column in tables 1 to 4. In this example, we need a copper conductor to supply a load of 380 amps. As the 400 amp panel has a temperature termination rating of 75 degrees C, we must start in that column. In Table 2, a 500 kcm conductor in the 75 degree column allows 380 amps. This will work for the above ground portion of the installation. In review of Table D11A, a 400 kcm conductor allows for 384 amps. This would work for the underground portion, but not the above ground portion, as Table 2 only allows 335 amps. The allowable above ground and underground ampacities for the 500 kcm conductors are both acceptable to supply the panel board. Accordingly, there is no transition required since the conductor is already acceptable. In this example, the installation complies with the minimum depth required in diagram D11, which is 905 millimeters. There is no length restrictions in the run length, except for voltage drop considerations. A voltage drop calculation should always be done to confirm the size selected will comply with Rule 8-102. Rule 4-004, Subrule 10 has been revised. The 2012 reference to use Tables 2 and 4 have been corrected. The 2015 code references Tables 1 and 3. Rule 4-004, Subrule 12, provides the requirements to calculate the allowable ampacity when more than 4 single conductors are spaced less than 25% of the largest cable's diameter. Derating factors shall be based on the total number of conductors. When it is necessary to reduce the spacing between single conductors due to site limitations or at termination points, the derating factors in Table 5C need not be applied when the length of the reduced spacing is less than 600 millimeters. If additional heating is generated in the cables because of the decreased spacing, the cables themselves will act as heat sinks. Rule 4-004 Subrule 14 is not new, however it has been reinserted since being missed in the last code. Multi-conductor cables run in contact with each other for distances exceeding 600 millimeters require derating by using Table 5C. The derating factor is based on the total number of current carrying conductors in all cables. Rule 4-004, Subrule 17, is for situations when a circuit is run underground and then emerges for termination above ground or in free air. The allowable ampacity of the circuit conductors change as the environment around the circuit conductors change. The transition occurs at the point where the circuit emerges from the ground. When 2 ampacities apply to the same circuit, the lower ampacity must be used to protect the conductors from overheating, except as permitted in Subrule 18. In this example, we have 2 ampacities for the same cable run. Based on Table 4, the above ground ampacity is 230 amps based on 90 degrees C. If installed in accordance with Table D10 and D10B, the allowable ampacity for this circuit must be the lower ampacity of 230 amps.
Rule 4-004, Subrule 18, can be applied to circuits run above or below ground. The higher ampacity is allowed throughout the run length, provided the lower ampacity length is restricted to 3 meters or 10% of the circuit length. The lower ampacity portion of the run will generate additional heat since it is carrying a current greater than its design. The higher ampacity portion of the circuit acts as a heat sink for the lower ampacity portion of the run. Where the lower ampacity portion exceeds 3 meters or 10% of the circuit length, or where multiple ampacity transitions occur throughout the run, detailed ampacity calculations must be performed by a qualified person. Subrule 18 does not restrict the circuit to a maximum of 4 conductors in total. The subrule restricts the installation to a maximum of 4 conductors in each raceway or cable. This allows for parallel runs for a 3-wire single-phase or 4-wire 3-phase installation. Further engineering would be required if more than 4 conductors were proposed. The termination temperature rating rules in 4-006 apply to all installations where equipment is marked. In this example, the higher ampacity is allowed on the above-ground portion. This length is restricted to 3 meters or 10% of the circuit length and is terminated on equipment marked for 90 degrees C. Remember, if the equipment is marked with a TTR of 75 degrees C, then Appendix D table notes tell us to multiply the underground ampacity by 0.886. We then have to check that the size corresponds with the 75 degree column of Table 2 or Table 4. If the size does not correspond with the 75 degree column, then larger conductors will be required for the entire run, or the installation of transition conductors will be required. In this example, the lower ampacity is required in the circuit because the termination length is 5 meters. The TTR rules in 4-006 also apply in determining the cable ampacity. Rule 4-004, Subrule 19, applies to the underground ampacity of conductors in Subrule 1D and 2D. In electrical engineering, the load factor is defined as the average load divided by the peak load within a specified time period. When the load factor is known, additional engineering calculations can be performed to determine the heating and cooling cycles of the conductors. These calculations can then be used to assign an ampacity to a given set of underground conductors, which will result in their temperature rating not exceeding manufacturer's specifications. Precise calculations must be made by qualified persons. A high load factor means power usage is relatively constant. Low load factors show that occasionally a high demand is required. When a load calculation is based on conditions which include a load factor, the authority having jurisdiction may request supporting calculations or documentation supporting the increased underground ampacity proposals. The Canadian Electrical Code ampacity tables provided are based on a load factor of 1 or 100% and provide the maximum continuous current which may be carried by that conductor within the prescribed parameters.
That's it for Part 2. Please move to Part 3.